Have you ever wondered what really goes on behind the scenes when you give a complex command to an AI? We tend to picture this single magic black box, but the truth is, it's actually a lot more organized and, frankly, way more reliable than that. So today, we're going to pull back that curtain and trace the journey of one single request, from just a vague idea all the way to a super precise, actionable answer. All right, let's get into it.
So here's the game plan. We're going to follow this request through 5 key stages. First, we'll look at the problem itself. Then we'll meet the AI's project manager, called the planner. After that, we'll see how the system picks the perfect tool for every single job. Watch the whole plan come together. And finally, really understand why this careful, step-by-step approach is the absolute key to building smart systems that you can actually trust.
Okay, so our journey starts with a pretty big challenge. You, the user, have a complex goal. But just tossing that goal at a giant language model and just, hoping for the best, that's a recipe for disaster. It's super risky and totally unpredictable. So let's anchor this whole explainer around one simple-sounding request. Analyze my expenses. I mean, it seems straightforward, right? But for an AI to give you a useful and, more importantly, an accurate answer, it can't just guess. It needs a process. It needs a plan. And this slide right here shows you everything you need to know. Sending that request straight to a large language model is basically a gamble. You're risking hallucinations, made-up answers, and the outputs are just not reliable. But a planned workflow that's designed for the exact opposite, it's all about deterministic execution, meaning it follows predictable steps, uses the correct data sources, and gives you reliable results every single time. So how do we get that super reliable workflow? Well, it all kicks off with the first, most critical player in our system, the planner. The best way to think about this is as the master strategist or the project manager for the AI. You see, the planner's job isn't to actually do any of the work. Its one and only purpose is to take that big, kind of fuzzy request from the user and break it down into a super clear, logical, step-by-step recipe. It figures out what needs to get done, essentially creating a to-do list for the rest of the system. And here's what that actually looks like. For our Analyze My Expenses request, the planner spits out a simple, clean 4-step plan. Step 1, get the data. Step 2, organize it. Step 3, do the math. And Step 4, figure out what it all means and generate some insights. See, each step is distinct, it's clear, and it's something the system can actually act on. Okay, so now we have our what. The plan is set. But we still need to figure out the how. And this brings us to the next hero of our story, the tool router. If the planner is the project manager, the tool router is the expert dispatcher, the one who assigns every single task to the perfect specialist for the job. So the tool router looks at each step from the planner's recipe and asks one simple question. Which tool in my toolbox is the absolute best for this specific task? It doesn't do the work itself, it just intelligently delegates everything. And this is how it makes those decisions. It's kind of like a great manager who knows exactly which team member is the math whiz and which one is the creative writer. The tool router knows Python is for logic and numbers, SQL is for databases, APIs are for grabbing live data, and the LLM itself, it's best for reasoning and, for generating language. All right, let's follow the plan. First up, the planner says we need to fetch transactions. This is all about getting raw data. The router sees this and immediately knows, okay, transaction data, that lives outside our system. We need to grab it live. So the perfect tool is an API call to a bank or financial service. It makes a precise, targeted request to get the real, factual data. No guesswork. Okay, next on the list, the planner has said, let's categorize these expenses and then compute the totals. These are pretty heavy on logic and math. The router immediately flags this as a job for the Python tool. Why? Because Python is built for reliable, deterministic math. I mean, you wouldn't ask a poet to calculate your mortgage payments, right? You'd use a calculator. It's the exact same principle here. Use the right tool for the job. And finally, we've hit the last step in our plan, generate insights. Now, this one's different. It's not about fetching data or crunching numbers. It's about summarizing everything and reasoning about it. And this is where the large language model finally gets its moment to shine. The tool router delegates this final step to the LLM, feeding it all the structured, factual results from the previous steps. The LLM's job is just to synthesize that information and present it as a nice, human-readable summary. We're using it for its core strength, language, not for facts it can't possibly know.
So the plan is made. The tools are all chosen. The execution phase is really just the system running the playbook. Each specialized tool does its assigned task one after the other. It's predictable, it's observable, and it just works.
Now, it's worth pointing out that there are a few different ways you can build one of these tool routers. You could use simple if this then that rules, which are super fast but not very flexible. You could use more advanced models that understand the meaning of a task, or you could even use another LLM to make the choice. But in most real-world production systems, it's almost always a hybrid approach, mixing the speed of simple rules with the smarts of advanced models to get the best of both worlds.
All right, let's bring this all home. We've seen the whole journey, but why go through all this trouble? Why is this planned multi-step system so much better? Well, it all comes down to a few core ideas that give you incredible wins in accuracy and reliability. At the end of the day, the single biggest, most important benefit of this whole architecture is a massive, massive reduction in AI hallucination. By using deterministic tools for factual tasks, we're not asking the LLM to remember things it was never built to store reliably. We're just letting it do what it's amazing at: understanding and generating language. This slide just says it all, doesn't it? Would you ask a language model for your bank balance? Of course not. That's just an educated guess, a potential hallucination. You'd call the bank's API, which gives you the ground truth, a verifiable fact. This system applies that exact same common sense to every single task, which is how you get reliability. And this whole thing is built on really solid software principles. First, always go for a predictable, deterministic tool when it comes to facts. Second, keep the what and the how separate. That makes the system so much easier to manage and grow. This structure also makes it a breeze to add new tools later on, and you can track everything that's happening, which is crucial for debugging and making improvements. Look, if you take away just one single thing from our time together today, let it be this. This separation of powers is the absolute key to building scalable, reliable AI. The planner writes the recipe. The tool router picks the right kitchen utensil for each and every step. You see, this isn't just theory. It's a powerful mental model for building really intelligent systems. When you start thinking in terms of plans and tools, you stop hoping for a good result and you start engineering one. So the real question is, now that you've got the blueprint, what complex, multi-step problem are you going to solve next?